This video is on binomial distributions. The binomial distribution occurs when the following conditions are satisfied: that there is a fixed number of trials, each trial has one of two possible outcomes, success or failure, the trials are independent of each other, and the probability of success is the same in each trial. If we have a random variable x and it has a binomial distribution with n trials and a probability of success of p, then this is our notation. I would always recommend writing this notation at the start of a question that it is a binomial, as there is a really good chance in an IB exam that this can give you a mark because it shows you've understood what direction you need to go in. First example, the number of bullseyes hit by an archer in a competition is modelled by a binomial distribution with 10 trials and a probability 0.3 of success. Find the probability that the archer hits exactly 3 bullseyes and then at least 3 bullseyes. So this will all be done on your calculator. So I'll write down the notation we're going to use and then we'll go to the calculator and I'll show you how to put it in there. So part A, exactly 3 bullseyes. So with this, we start with our binomial. So we have x, little squiggly line, b for the binomial, and our number of trials is 10 from the question and our probability of success is 0.3. So this is the information we need. Exactly 3 bullseyes. Now, when we go to our calculator and we look at binomials, you will see that often you are given a binomial PDF and a binomial CDF. Now, PDF we use for exact amount of whatever we're looking at. Now, I'm going to put the notation here that you'll see in your calculator, which will look like this. I'm going to be doing it on the TI Inspire. And we always have our number of trials first, which is 10, the probability of success, which is 3, and the exact amount we want. I'm going to go to the calculator now and show you how to put this in. We want to go to a calculator page. We go to Menu, Probability, Distributions. Then in here we're wanting Binomial PDF. So you'll see here it's right at the bottom. As we are doing an exact number of trials, we want the Binomial PDF. Click on that. And it wants our information. So our number of trials was 10, our probability of success was 0.3, and our x value, it says here it's optional, and I'll show you what that does in a second, but we do want exactly 3, so we can just type 3 in there, click OK, and you'll see there we have our probability of 0.266828. Now I'll just show you what happens if you don't put a number into that x value at the end. So Menu, Probability, Distributions, Binomial PDF. So say if here I did 10 and then 0.3, and I didn't put an x value in here, it will actually bring up the probabilities of everything. So this is a probability of 0, 1, 2, and here you see 3, which matches what we wanted, and so on, all the way up to the 10th trial. So that you can do it that way and it gives you all the probabilities. Often though, it is just easier to do the way we did it first because you just get the one answer and you don't have to search. As you saw from the calculator, we got an answer here of 0.266828, which simplifies down to 0.267 to 3 significant figures. Now part B, we want at least 3 bullseyes. Now because it's an at least and we're looking at more than one outcome, we'll be using the binomial CDF. Now when we put it into there, we need the number of trials and the probability of success, but this time we need our lower and upper boundaries. So at least 3 bullseyes mean we are wanting to go from 3 bullseyes all the way up to 10 bullseyes. I'm going to go to the calculator now and show you how to enter it all. So to do this, Menu, Probability, Distributions. Now here you see at the bottom we had the binomial PDF. If you just carry on scrolling down, you'll see the next one is binomial CDF, which is what we want this time because we have the range of trials we're wanting to look at. Put in our information, number of trials is 10, probability of success is still 0.3. Now lower bound will be 3 because we're wanting at least 3 bullseyes. Upper bound is 10 because our maximum amount of bullseyes we can get is 10. Click OK, and you'll see here our probability of that is 0.617217. And as you saw from the calculator, we got an answer of 0.617217, which is approximately 0.617 to 3 significant figures. Now the next thing with binomials is we can be asked to find the mean and variance. So if we have a binomial distribution, then EX equals N times P. Now you remember when we've looked at EX before, this is the expected value, and as we've also talked about, this also is the mean. So just remember that e to the x, we can see it as the expected value or the mean. We also know that the variance of x, so VAR, x equals NP multiplied by 1 minus P. Now, VARX stands for variance. This also comes very much into statistics, and if you want some more information about variance, which also links the standard deviation, you can go and watch that video too. One thing that is really important to note, that variance does actually equal the standard deviation squared. I'll just write SD for now, standard deviation squared. The other symbol for standard deviation is this type of symbol there. So you'll see that for standard deviation. But variance, it's important to note that it is equal to standard deviation squared. And standard deviation and variance are all look at the spread of the data. As I said, comes a lot more into statistics, so you can go and do some more research there if you wish. Next example here. Dima guesses randomly the answers to a multiple choice quiz. There are 20 questions and each question has 5 possible answers. If x is the number of questions Dima answers correctly, find the mean of x and the standard deviation. So what we need to do in this instance is work out what our number of trials is and our probability of our success. Now there's 20 questions in total, which means that's our number of trials. That's how many questions she's going to be guessing. And each one has 5 possible answers, so the probability of it being correct is 1 out of 5, or 0.2. Now you can put 1 over 5, or you can put 0.2 in your calculator. You can do either, doesn't matter. So when we're working out the mean, which is our expected value of x, and we just use the formula we looked at before, which is n times p. So in this case, number of trials, which is 20, times by the probability of success, which is 1 over 5, which will give us an answer of 4. So she would be expecting to get 4 questions correct if she was to randomly guess on the multiple choice quiz. Then part B, the standard deviation. Now this comes into what I said before, that the standard deviation squared equals the variance. So standard deviation equals the square root of the variance. Now that's going to be really important when we're working out this question. So our formula for the variance that we had already is that we have n times p multiplied by 1 minus p. Put in all our information, n is 20, probability of success is 1 over 5, multiplied by 1 minus 1 over 5. And in your calculator, you'll find the answer to this is 3.2. So our variance is 3.2. Now to work out our standard deviation, this is the square root of the variance. So the square root of 3.2, which is 1.79. And that's the end of binomial distributions.